Hey everyone, so I just got a new microphone and I thought it would be good to make a video. This video will be detailing the technical aspects of Clay. I'll be going over the contract source code first, then some of the tests, which you guys haven't seen yet, and also I'll be going over the shaders and the rendering code as well. Okay, so let's get started. I will start with the contract code right here. So it says clearly at the top, I did borrow a lot of inspiration from the anonymized contract, especially for the trait generation. This part here should look very familiar to a lot of people that are familiar with that contract, but I did modify a fair bit to kind of save gas in certain areas and kind of certain recommendations here and there as well. Although in terms of gas, the contract doesn't really do anything particular. Like there's no assembly or anything like that. It does use ERC721A, but frankly speaking, it's like 1 mint per address. So 721A doesn't do too much here. The reason I am using 721A is because it's a very heavily audited and well-written implementation of 721, and it's easy to just drop it in because if you don't use 721A, even if you're doing 1 mint per address, what ends up happening is you run into issues with, for instance, certain aspects like the counter, the total supply. You'll have to implement your own total supply counter, things like that. So basically there's a lot of boilerplate that 721A takes care of for you. Even if you're doing only 1 mint per address, I still recommend going with it because it's a pretty good standard and it takes care of a lot of the groundwork. So starting right at the top, yeah. So there's some attributions here. You can see this interface. So this is somewhat unique. This is basically a just an interface that allows me to upgrade the attributes engine in the future, and this is going to be instrumental to Clay Wars because I'll be deploying a new contract that looks something like this, that implements the iClay trait modifier interface, and this contract will be able to override the attributes, and those attributes will affect the 3D rendering and also the SVG preview as well. Yep, so just going from the start, just got some basic boring things here like supply, price, etc. We can skip past that. This stuff is somewhat interesting. It's the whitelist method. It's the ECDSA method that a lot of projects are using. I did a short Twitter thread on how I decided to put all the signatures on the front end, and there's no security issues with that. I think it's a pretty straightforward way to do whitelisting. And then here, what we have is the HTML code. So originally I wanted to upload the HTML code base64 encoded, but I realized that base64 encoded data is actually takes more space. So although you might say that you're saving gas, but I'll get into that later because this base encode function only gets called on view function, so there's no it never gets called when state is changed, so there's no actual gas to spend anyway. So I just ended up uploading it plain and base64 encoding it on the fly. So let me take a step back there and explain what exactly this is. So the HTML is split into two parts. There's the first half of the HTML, which is basically just the first half, and then there's the second half. And the reason there's two halves is because all the way down here, where is it? Animation. Yeah, so all the way down here, I basically combine the first half and the second half, and in the middle I just chuck in the attributes, and it's the exact same JSON file that you would get, that you would send to OpenSea to tell it about what attributes your Clay has. Okay, so going down, Yes, it's just some boilerplate. So this part, very similar to Anonymize. It's basically the different tiers of the traits. It's called tiers, but it really means like this is the trait type. So the trait type here is base. So here you have clay, stone, metal, and obsidian, and you can see that the chance for getting obsidian is 1 out of 10, basically, because all these numbers they all add up to 10,000 exactly. The chance of getting diamond is 1 in 1,000, and that's why there's 3 diamonds in the whole collection. Yep, so that kind of explains that. Here's just the base 64 encoder, which I borrowed from Anonymize, and also well, actually, I think this one I took it from Inu's Kong's contract. Yeah, this one here. But I noticed that Anonymize had it as well. It's not in here. It's in their util library. But yeah, I think I took it from the Kong's one. Let's see. Yeah, this is just a bunch of utility functions for types. Generate metadata hash. Yes. So okay. So this is where a little whoopsie occurred, and probably shouldn't be saying this, but there is a small bug here in the contract, but at the end of the day, it didn't actually end up affecting anyone, which is great. But basically, what you might notice is that the trait distribution in Clay is a bit funny, and I'll explain why that is. I'm quite surprised no one's commented on it so far, because it's not very noticeable. It's basically just that the random the randomness is it's not quite as random as it could be. So going into some more detail, basically, if you go over to how Anonymize did it in rarity gen hash, yeah, right here. So basically, hash in Anonymize is a function that changes state. It's not a read-only function. And so what it does is it has a SeedNonce, which is in storage. It starts at 0, and then every time you mint a mouse, it'll increment the SeedNonce. Well, actually, for every trait, it'll increment the SeedNonce here inside this loop, and then it will concatenate it so that this is basically a random function that takes a seed, and what they're doing here is that they're combining the block timestamp, the block difficulty, the token ID, the address. C is like it's just another custom set number that increases randomness, pretty sure. And then SeedNonce is this here. Okay. So what happened was I was discussing with Mousedev briefly about on-chain, and he did mention how future implementations of this, he would prefer them to be read-only, right? So I was like, yeah, that's cool, because that would save a lot of gas. You don't have to do all this trait generation during minting. You could just do it on the fly. So I decided to go with that for Clay. I thought it was a neat idea. And so I took the hash function and I changed it so that it takes the token ID and it takes my custom seed. Now what I failed to realize until sometime after mint is that the SeedNonce here, when I took it out, I should have put something else in. So if you look at Anonymize here, they don't actually put in the trait ID. Now what they could have done is they could have done this, for example, and it would increase the randomization, but there's no point because they already have the SeedNonce. This is already enough. But what's happening with Clay is that without the SeedNonce, I would need to add something in, maybe just right here, so that for every trait, the random number calculated is different. So what's happening now with Clay is that the random number that's calculated for every trait is actually the same for that same token. And so what ends up happening is you get a very top-heavy distribution. Basically, all the obsidians got the diamonds, and the like things like mouth and eyes and large, or like they're more likely to show up in the more rare tiers, so they kind of get grouped together like in bands. It's a bit tough to explain without a diagram, but it's basically just a slightly more uneven distribution of traits, where the rare ones tend to group together and the not rare ones don't group together. Now, for me personally, I don't see this as a big problem because Clay is designed to be upgradable. So everyone that got the more base versions, they can basically, because their floor price is going to be like a lot lower. And there's certain elements in Clay Wars that allow you to own multiple and then have synergy so that they could generate more together, generate more mud and use that to upgrade. So for instance, rather than owning one expensive clay, you could sweep 10 cheap clays, and that could provide you, you know, a decent advantage over one expensive clay. I still have some numbers to tweak with the balancing and stuff like that, but essentially I've designed the upgrade system so that this issue that I just explained kind of becomes a bit of a moot point anyway. And I'm really excited because right now with this, we're not seeing certain combinations, so such as clay with ruby, for example. Like there's no base clays with ruby on the market right now, but once the upgrades start, you could totally do that. So I'm looking forward to the upgrading because it'll essentially correct this issue slowly over time. Yeah. So getting back to the rest of the contract, because I probably go on about this for hours. Yeah, so that explains that. So overall, a slight issue, but it didn't affect things too much in my opinion. Now going back to, let's see, rarity gen. Yeah, this is just standard stuff. This one here. So this is where the proxy contract gets called. So when I set the Clay Wars trait modifier on here, it'll basically override all of this. And what I'll do is I'll just take all this and re-implement it using the same seed, etc. on the Clay Wars contract. And then I'll be adding in certain traits thanks to this. And I've tested it out as well. I'll show you the test later. And yeah, here's like if it's using a placeholder, just return an empty array. This is the same as this. It just calculates the hash first. The SVG. So the SVG is inspired by the contracts above, doing a slightly more, because there's not that many traits that I care about previewing on the SVG preview. This is basically only going to show you the base material, the ore, and how big the ore is. And that just provides you kind of a quick glance from the OpenSea market view. Now people have been asking, like, can we get the 3D preview in the OpenSea market view? And what I'm going to say is you absolutely can. So what I've done here is if you scroll down to TokenURI, I've actually put in override image URL. And I was careful not to prepend the base 64 because that would have messed it up. But yeah, I put the override image URL here so that what you can do is at a later stage, I could, for instance, create a server that pre-renders the images, the 3D images, and then overrides it with that. But it'll have to be either kind of an off-chain solution or a proxy server that downloads the HTML, renders it to like a headless Chrome instance or something, with WebGL support. And that's the tricky part. The headless Chrome is going to need WebGL support, and then spits out a preview. I've been mulling over that, but at the moment I'd rather focus on Clay Wars. So that particular feature is not high on my priority list so far. And to kind of keep things 100% on-chain, I'll probably keep the SVG, this SVG preview for a while. But yeah, in the future, it's definitely a possibility to implement it so that it spits out 3D previews. So yeah, and if it's using the placeholder, it just doesn't show anything. So if you're observing Clay during the pre-reveal, you would have seen it was just the word clay in the bottom right, because this part here was excluding the body and the R. Yeah, it's just a bunch of SVGs spliced together. I'm not like an expert on SVGs or anything, but it was pretty straightforward to splice SVGs together here. Okay, so that part is pretty much explained. This part is really simple, but it's also my favorite part of the contract, because this is kind of where the magic happens for the animation URI. And I think I went into it a bit earlier, but I'll just reiterate real quick. It's the first half of the HTML, then you splice in the JSON attributes, and then you splice in the end HTML. And when it was using the placeholder, it would just be the placeholder HTML, which was like that bubbling orb, the bubbling ball of poo, some people called it. Okay, now moving on to TokenURI. Yeah, so this is basic again. It's just a bunch of JSON stuck together. You get your SVG with a possible override in case I want to move it to a proxy server off chain, or do whatever I want with it. But right now it's all on chain. And then the same with the animation URI. And for the animation URI, I also put an override, and I went into this a bit of detail in one of my previous Twitter threads, where I talked about how OpenSea had this CSP, content security policy, where it wasn't letting the JavaScript execute on my page, and that meant the WebGL and everything just wouldn't work. And so I actually went and I wrote a whole proxy server that uses Infura to grab this on-chain animation URI from the contract itself, and then publish that to OpenSea, and then I would put that proxy server as the override URL. And that's actually, I still considered that 100% on-chain, because there was no data stored off-chain. It was just getting processed differently in a roundabout manner when you think about it. But I didn't end up having to do that, because I checked back like a week later, and it was working without the proxy server, and I was a bit shocked, and it's still working. So maybe just the day I happened to test it, OpenSea was making some changes to their front end or back end, and it was just unlucky timing at the time. But luckily it's not required. So going down a bit, yeah, some people commented on this. Yeah, I mean, I could have done something like this, right? But the thing is, like ERC721A, it has like this maximum batch size or something. I'm not sure what I set it to, but I figured for devmin it's fine. I'll just, yeah, it's not even in the constructor. So there's a batch size somewhere, and if you exceed it, it will complain. So I just kept it at 1 here, because I don't want to spend too much time on saving gas for devmin, like the comment says. Signers, yeah, so this is part of the whitelist method. 2 different signers. I don't want to go too much into the sale method. Like this video is more to cover the on-chain part, like the art and things like that. So this lets me set the contract for the trait modifier. So this is important in Clay Wars. And this lets me upload the base HTML. Now the base HTML is like 99% of the HTML, because I'll show you guys real quick here. Where is it? Okay, hopefully I don't expose my private keys. This is basically the base HTML here, and then this is the end HTML here, and so you can see this is very small. This one, when I uploaded it, it cost about 0.7 ETH, I think. Yeah, so it was about this much data to upload for the star HTML. In total, it's about 15 kilobytes. And it costs about the same to upload as uploading like 500 whitelist addresses if you're using like the very old whitelist method where you just throw everything on the contract. This HTML costs about the same as 500 addresses. I think it was like 1.5 million Gwei. Okay, so, yeah, so this is all pretty straightforward stuff. Here's the minting parts. One thing of note here is this part where there was a YouTube video made by some white hat hackers about Clay, where I had this the wrong way around. I don't know why, but I did. And not only that, I also wasn't forcing whitelisters to be users because I thought that only mattered for public to prevent botting, but it turns out that it also opens up your whitelist function to reintroduce the exploits. So basically it was like this, and they caught it and they got in touch with me. I'm very grateful. So what I ended up doing is fixing it by adding that back in here, and then reordering this so it doesn't so it actually sets this before that. Oh god, Freemint still had the issue. Well, guess what? No one exploited it because Freemint was only sold on marketplaces, right? So the reason Freemint wasn't exploited is because Freemint was only sold on marketplaces, and those marketplaces required you to connect to a MetaMask wallet. Now, yeah, there would have had to be some and this was this contract with this source code was uploaded way after I collected all the Freemint addresses, so it would have been impossible for someone to like look at this, make a contract that exploits it, and then submit their Freemint address to me because I would have already collected them. Yeah, so okay, I dodged a bullet there. Wow. That would have been disastrous, but yeah, it was, yeah, it was like pretty much 0% chance of getting exploited because of the fact that it was only sold on marketplaces. Okay, so let's see what else here. This is just some ERC721 stuff. This is just a way to fetch the owners. Okay, now moving on to the tests. So I've been planning to move my test to TypeScript because I like it more, but for now I just it's just in JavaScript, but you know, works fine. And so what I do here is I test the setup. I test you know, I mint a few, and then I have a look at like the token URIs that come out, the animation URIs, and basically I can copy paste these directly into my browser and it will start rendering. Yeah, and I'll look at a few of the attributes and things like that. I test the trait modifier contract. So actually this this ends up spitting out. By the way, I should be what you should be doing here is you should be doing like a expect you know, expect, like this should look like this. Be 2b. What's going on? Or is it just equals? Yeah, equals. Sorry, it's chai, not jest. I'm used to jest. And then you would put in what your attributes should look like. Yeah, and then you would fill that out, and then it would assert if it's not equal. That's what a test should look like. I've just been using for this because I like to eyeball the attributes a lot, so I've just been putting it in I've just been printing it out and eyeballing it and seeing if it looks okay. But yeah, like for real, don't just this is, I would say this is bad practice. Don't console log your things. You should actually be using an expect statement and asserting against them. But for me, it's just for these kind of these more visual elements like the attributes, the on-chain animation URI, etc. Because I can't really think of a good way to like to automate, you know, testing that from visual perspective. But then I'll show you the assert. So when you come down to say the actual minting functions and things, this is where I start putting in the asserts. Yeah. Oh, it's .2.b. Okay, my bad. Yeah. So So for the more visual things like the attributes, I'm just console logging and eyeballing it. But for the actual minting functions, I do actually have asserts in here. So bunch of tests here. These are a lot of standard tests that I run during my audits. Like you can't set the signers when you're not an owner. You can't mint tokens outside of certain sale phase. You can mint tokens in certain sale phases. You can't mint without whitelist. You can't mint with someone else's signature. You can withdraw. Just a whole bunch of. There's about 33 tests in here total. Yep. So that kind of sums up the tests and the contract.